This conference will now be recorded.
So we have discussed two approaches from the pharmacoepidemiological research point, the assessment of vaccine safety. Now today we are going to understand the other approaches. Now whenever we give vaccine, and adverse events are produced, then you need to establish the link, causality link, what is known as causality link. In most of the cases, the focus should be to establish the causality or the cause directly. That can give the solution as well as helps the doctor to prepare if there is an adverse event that occur during the or following the administration of vaccine. Now, why there is a problem in connecting this vaccine with the adverse event is because of the one reason: it contains more than one component that we have clearly understood in the last class. Now, you do not know what caused the problem. But if vaccine has produced the problem, then you may have to, separate all the separate out the issues with respect to its component by studying the safety profile of each component and their probable effect that can be produced when it is injected to human beings. But at last, it should be linked. It so happens that the component may not be the cause, but repeated injection would have caused the problem. So then you have to find out, and we have to find out how many times the injection was given, so that the patient has become hyper responsive instead of normo responsive, has become the hyper responsive. So that needs to be linked. You need to find out whether adverse event occurs without vaccination also. So this clearly gives an idea that the body is involved in producing the adverse event than the vaccine. So you need to link whether adverse event is getting produced without vaccination. And sometimes it so happens that adverse events are produced in the normal human being. You can see here, when we give smallpox vaccine, it can produce myopericarditis, that is the inflammation of the outermost layer of the heart. In young, healthy adults, see, there is no doubt that smallpox vaccine protected the healthy individual from the attack of organism, but in a way of doing this, it has produced myopericarditis. So this is a problem to be identified. Then only we can establish the link. So that is not possible in one or two reports. You need to collect the data from large population. So that is where the pharmacoepidemiological study helps them, right? So in this assessment of causality is very important. I hope this is understood. Can we move on to the next approach? Manoj?
Yes.
Yes, sir.
Exposure. Another approach is exposure. So the documentation of the adverse event is very difficult with vaccination. First of all, it is done for all large population, number one, and it is very difficult to contact each and every person in order to know what happened and try to relate the adverse event with the vaccine. So what can be done so that we can have a track is that the vaccination to all aged population can be initiated. That means to say that the population who are aged 60 and above can be documented. So now in this case, even though the elder people are large in number, but the frequency with which they come to the clinic will be more, and those people can be easily tracked. So such kind of mandatory exposure to certain population helps to document the exposure status. If we do not know the exposure status of the vaccine, it is very difficult to link adverse event with the vaccine or the efficacy with the vaccine. Both are very difficult. So the pharmacoepidemiological approach says that to have a complete documentation of the vaccination to all to all aged population, it is always better to focus on one population. So this helps to classify vaccine exposure status. So like for example, children, how many vaccinations have been done? So there is a separate database. Elderly, there is a separate database. The large population is adult population. So before adult population also, there is a adolescent population. We have infant population. We have adolescent population and adult population and the elderly population. So restricting your documentation to one set of groups and creating in a safety database, creating in a safety database in order to have a link helps us to know clearly that how many people received vaccine, among them how many people received vaccine frequently, then how many suffered from adverse events. That is how the vaccine exposure status is very important in the complete documentation of the vaccine. I hope this is clear. Can we move on to the next approach?
Yes, sir.
Any doubt? Somebody asked something? Okay, next approach is that outcome approach. See, like now we have seen that events, the occurrence, correct? Vaccine, after the administration of the vaccine, we have heard events, occurrence. Now, what is the difference between occurrence and the outcome? Both are result outcome only, but outcome will have a definite, definite consequence. Definite consequence. So now, usually adverse events will be less. So if you see here, adverse event following the vaccine administration will always be less among large population. This is very clear for us. So in order to conclude with evidence, you need to increase the number of events by covering large number of population. and to prove statistically. So that is where pharmacoepidemiological studies helps you to cover up large population. Now, epidemiology also helps in order to understand the adverse outcome, where it depends on the number of exposure to vaccines, number of exposure to vaccine. So that will give you the proper outcome. So solidly the consequences are produced in a patient so that the treatment is given in order to treat the adverse drug reaction outcome. That clearly explains that how pharmacoepidemiology helps to relate it. And now when the adverse outcome happens, that is a clear consequence, clear result happens, and when the treatment is given, then it also helps us to understand causality, that is the link between the adverse outcome and the vaccine. So this is where the pharmacoepidemiology helps to assess the risk, say, associated with the vaccine. Not only it helps to assess this, but it also helps to calculate what is known as risk interval. It is the time between the first administration of vaccine and the appearance of the consequence. Okay, it is the day on which the vaccine is administered and the day or the time at which a result is produced, or there is adverse consequences produced. So the time between these two is known as a risk interval. Now, in such cases, what is the problem in establishing the causality? This is what we need to understand. Let us understand through discussion that what is the problem in assessing the causality whenever the vaccine is given, if this is the approach, right? So let us see. Mega. See, when the adverse outcome is produced, when risk interval is produced, what is the problem in assessing the causality? Do you think any problem is there?
Sir, actually, I didn't get, sir. Can you repeat?
What is the problem in establishing the causality when we are assessing risk interval? I have told you that vaccine, when it is administered, the risk interval can be calculated. That is, the risk interval is the time at which the vaccine is given and the result is produced. So the time in between is called as risk interval. When we can do this, what is the problem? Why we cannot assess the causality when we give the vaccine?
I don't know, sir.
Okay. Marlene, Sarah?
Sir,
Answer, please.
so the prediction of the cause will be difficult.
Why? Why that is what I'm trying to understand. Why do you think that?
Because so many other factors will be coming.
Okay.
So it
Is
will
there
be
any other?
difficult to distinguish between the risk and the other factors,
Such as?
such as any other diseases or effect of any other drugs, something like.
So that is why it is difficult.
Yeah, I think so, sir.
Yeah. Navindra? Nikita, Ria Pillai,
Sir, due to the any other diseases, properly, I don't know.
any other diseases? Okay. Ria Sara,
So certain side effects may take a longer time, or it may be produced soon after the vaccine is being administered. So then correct detection of data may not be possible.
so you mean to say that it is not possible for those adverse effects that are produced after long period, but it is possible for the short period adverse effects.
Yes, sir, short period ones. Because if during the interval, if the data is not collected, then we cannot say, right, which ADR was produced after the vaccine is administered.
Yeah, you are right. Correct. Very good.
Uh,
Yeah, somebody wants to say something? Go ahead. Yeah,
yes,
the answer. Yeah, somebody. Yeah, please go ahead.
that's it, sir.
Sorry.
No, miss, no, sir. I wanted to tell that. That's it.
Okay, thank you. Okay. So she is right in the sense that see when the from the day of vaccine administration, if the result is going to be occurring say in 24 hours or 44 hours, 48 hours, they can you can relate it. But if it is going to produce after 6 months, you do not know what factor would have influenced during this 6 months time, and also it is very difficult to calculate the risk interval. So that is why pharmacoepidemiological studies helps to assess the risk interval if it is for the shorter period and frequent adverse event, but not for the rare events. It is very difficult to calculate, right? So that is how the pharmacoepidemiological approach has the influence on this uh, methodology. Next is that study design, analysis, confounding and bias involved in this assessment. Okay, so usually two studies are used. Cohort studies, case control studies are frequently used in order to assess the vaccine safety, because we already know that in these studies large number of population is covered, correct? So picking up the adverse event from few patients becomes easy. So that is why these two studies are frequently used. But in cohort study, the problem is that confounding variables are more. Confounding variables are more. So that is why there is a chance that biasness is involved, and also it is expensive. Confounding variables can be, say, for example, disease. Cohort study means like you want to group the same number of patients who are expected to have the disease or who are having particular disease. So what happens that so the disease factors or the factors, physiological factors will become a variable, can become can be a variation, and that will result in the problem of giving the biased data. In addition, it is expensive also. There is, so what happens is that so the data may not be may not be clear or precise to base something decisions. So in order to avoid this problem, what they do is that they use what is known as case control study. Frequently, case control study is used. Here, what they do is that they try to compare the sample population with the selected event-free controls. So that helps to clearly relate that, okay, in control adverse event is not produced, but in patients it is produced. So you can easily match. You can match for the gender, you can match for the age, you can match for the disease, you can match for the diet. So you can do so many matches, so that if any variation is produced, naturally we will have a base that, oh, this is because of this particular problem. So that is why case control studies are used much frequently when compared to cohort studies. And also any age variation here and there can be adjusted using a statistical analysis. So even you can use self-controlled studies, self-controlled study design. Let us understand what is the self-control. We have already recalled, but just to clarify, Sufficient, what do you mean by self-control studies? Marlene, Sarah?
Sorry, sir, I'm not able to recall.
Okay, Jerly? Sharin Babu? Sonam? Sri Saileka? Sorry, Sai Shileka?
Sir, self-control is individuals where individual will be controlling. Comparison is made within the individual, where individuals act as their own control.
Yeah, correct. So suppose, for example, the group of patients having a disease. So baseline, the day when you did not administer the vaccine, that is the first data which they have collected. Then second day, they have administered the vaccine. Now from second day onwards, what all the changes that takes place, that data will be compared with the day one. That is known as self-control study. Each patient will act as a control on his own or on her own. That is called as self-control study design. So they are more accurate when compared to even case control as well as the cohort studies, because any variation that happens, it is with respect to self. So that is the advantage. So you can use such kind of studies in order to reduce the biasness. Let us see self-control are of two types. Self-control case series, you can use it, and also cohort study of vaccinated individual. Risk interval data can be collected. So either you can use the cohort study, you can do cohort study involving only those individuals who are vaccinated. So you will have a common outcome. So otherwise, you need to have a self-control case series. Even though both are both can give their own data, self-control case series will have edge over cohort study because of the confounding variables. Now, confounding variables can be anything. Maybe it is physiological, patient-induced factors, and other patient-related factors. So let us understand which are those confounding factors that mainly affect the vaccine safety. First one is low socio-economic factor. So what happens is that first of all they would have taken the vaccine, but they don't have so much of strength enough to tolerate their dose of the vaccine because their economic status will be poor, or maybe the place where they are living will be contaminated. That is making the person to be susceptible or influence the adverse consequences. So low socioeconomic factors also play a very important role in creating the bias by acting as a confounding factors. Non-vaccination cases. Non-vaccination cases. For example, patients would not have vaccinated earlier. Now today you want to vaccinate. So the body is receiving the vaccine for the first time. So it is hyper responsive. So that is what it leads to the problem of biasness. Now the next one is preceding illness. So today you have given the vaccine in order to protect certain one particular disease, say disease number 1. But the patient is already having disease number X since very long time. Now what happened? This vaccine, which is containing microorganism, may not be able. Maybe its effect is worsened by the previous illness. Number 1. Or it may this vaccine may produce hyper-responsive, or it may produce an adverse consequence because of the influence of the preceding illness. So because of these factors, confounding factors, biasness usually comes out, especially in the cohort study, more frequently when compared to case control study or a self-control study. So you can see here the relationship, how they have related this biasness also. So confounding variables which happens at different stages actually. So risk of adverse event in unvaccinated children who lack the contraindication. Say for example, certain children are highly allergic to ground nuts or chocolate products, okay, or any other food grains. Now if they don't have and you did not give vaccine, still there is a risk because of the influence of the illness which they have. So you need to consider that when you're trying to consider the confounding variables. The children who did not receive vaccine but did not have contraindication will also have a risk of adverse event. The next set of patients are true relative risk of adverse event associated with vaccination. These are the people, okay, these are normal people where you have given the vaccine. Yes, there is a risk associated with that because the adverse consequences are produced. So there is a one group where there is a clear and direct relationship that is called as true relative risk of adverse event. The risk may be more or maybe less, but there is a relativeness in that. But these are the people who are originally at risk. Next one is the relative risk of adverse event associated with contraindication. Just because the contraindication is there and you have given the vaccine, adverse effects may be produced. So you need to take this factor into consideration while doing the study. See, the more the exclusion and clear inclusion criteria you have, your study becomes very strong. But if it is reverse, the study becomes weak. Now you can see here population of children with contraindication. Here children without contraindication, but here with contraindication. Vaccines can produce the adverse consequences. Here you can see one more group of children without contraindication. Proportion were vaccinated, but without contraindication. Among those children without contraindication. Proportion of vaccinated among children with contraindication. So whenever you are giving the vaccine, you have to take into consideration all these 6 variables which may pose as a confounding variables. These factors may be associated with the patient illness, or the socioeconomic factors, or sometimes we know that non-vaccinated cases but with contraindication, without contraindication. So only if you take these things into consideration, you can design proper study in order to assess the vaccine, as well as you can design the study in a manner that without biased results. So restricting the confounding variables is very important, right? So that finishes the vaccine safety chapter, how the pharmacoepidemiology helps in doing this. Just I want you to go through these slides in order to just recapture, because this is something little bit difficult here and there because of no connection with the actual concepts, and very vague connection. Just I'll keep flipping the slides, just go through it from the first beginning of this part. If you have any doubt in the meanwhile, please ask me. Yes. Yeah. All of you uploaded the assignment of the field study research project. Manoj, they have done it.
Sir?
Research project design for the field study. Have you uploaded the link?
No, sir. We have yet to upload it.
You have the format correct in your hand from Rini madam?
No, sir. I don't think.
Oh, she was not given the format. There's a particular
No, sir.
format. Oh, okay. I'll okay. That format. The problem is that it is with respect to clinical study, but your study is a field study. So using the same approaches, no, the design of the field study. So using the same approach, you write the article. I mean, write the project and upload. Okay, all of you remember that. Whatever the format with which we have designed the study. So using the same format, you design your field study and upload. For the project work which you have taken, you can discuss your project. I mean, you can take up your own project, not a problem at all. But how can you do that in the form of field study? Just propose it. Okay. Submission is individual, but you can take up the same group of project. I think Manoj has cleared the doubt to you, your classmates. Manoj?
Yes, sir. I'm there.
Manoj, did you clear the doubt? They
So
can
no,
take up.
actually, we didn't get like how to do it. Like.
Okay. Now you can take your own project. I have told you one day you have asked me, right? Okay.
Yes, sir. What and all we have to implement.
Okay. Now what you can do is that you can take up the same project, what you have proposed. So using the same project, you can design using those parameters. put a research question, and then you say how many people you need, how to do that, methodology, and everything. In the same pattern, you write it. Got it now, everyone? Anybody has any doubt? Anybody having any doubt? You can discuss now also. Not a problem at all. Still we have a time. All the research groups must take their own project to design and upload. That will have a marks, and you can contact me at any time. Now also you can contact and discuss the things. Otherwise, if you are very clear, just go ahead with the reading and ask any questions. I'm going to fix the data submission of your assignment. Today is 13th. By 20th, everybody should upload the assignment. Is it clear? 20th. Manoj, I want to conduct a class test tomorrow.
Okay, sir.
Please update me whether you want your classmates wants to take it in 2 tests or in 1 test itself by evening.
Okay, sir. I'll ask them and I'll confirm you.
Yeah. I'll spread the notes also through your WhatsApp group. Then update me by evening.
Okay, sir. No issues.
Okay. Okay. Anybody has any questions regarding what we have discussed? Okay. If there is no doubt, now we will disconnect from each other. Thank you very much.
Thank you, sir.
Thank
Thank you, sir.